Hi everyone. So we've been working on area of polygons, and I just wanted to do a little trig review because now we're going to get to find area, but we may have to use trigonometry. So let's just remember SOHCAHTOA. It refers to the relationship between the side lengths in a right triangle and the angle measures. So here's a right triangle with an angle of A. And so the sine of that angle, so the sine of angle A would be equal to the ratio of the opposite leg over the hypotenuse. So CA would be the cosine of the angle. So we write that as cos, right? So cos angle A is equal to the adjacent leg over the hypotenuse, and the tangent of an angle is equal to the opposite leg over the adjacent leg. Okay, so we're going to have to be able to use those to either find angles or find side lengths to help us find our area. All right, so let's just make sure we're comfortable with the calculator. We want to make sure that our calculator is in degree mode. All right, and let's get some trig ratios. So if I have the angle, which each of these is giving me the angle because that location where it is the angle measure. It's telling me 90 degrees. I would just put in sine of 90, and I'm going to get 1. Okay, the sine of 90 is 1. The next one, the cosine of 15. Again, I know it's the angle because it doesn't equal a ratio. I'm in the wrong mode, I bet. I'm in degree mode. Okay, so cosine of 15 is 0.96. I did something wrong. Oh, that's right. So 0.965. Round to the nearest tenth. So actually, we're going to round this to the nearest hundredth. So 0.97. So 0.97. And tangent of 73. Tangent of 73. So tangent 73 equals, again, we're getting the ratio 3.3. So 3.3. All right, so we have to remember how we solve equations when they involve trig. If I'm solving for any variable, I suggested creating a proportion and then cross multiplying. When we do cross multiply, we want to put the 15 in front of the sine 23. We never multiply it to the 23. So we set up our equation like that, 15 sine 23. Then we grab our calculator and we put in 15 sine 23. And we get 5.9. So x equals 5.9. All right, let's look at C. This one's slightly different. When we cross multiply, when we make it our proportion, we cross multiply, that y goes in front of the tangent 60, still equaling 3 times 1, which is 3. But now I'm solving for y, so that means I actually have to divide both sides by the tan of 60. So we divide by tan 60. And so look at the difference in the equations. This one's a division, whereas the other one was a multiplication. Okay, so we've got 3, let me clear, 3 divided by tan of 60, and we get 1.7. All right, so that's how to solve an equation that involves trig. But now we could also look at triangles where we have to solve the triangle using trig. Now, a couple of things. If I know it's a right triangle, I normally go to see if I can use the Pythagorean theorem first. But I don't have enough information in this case. Then I would jump to my special right triangle relationships, which I also don't have enough information in this case. But I do notice that I have an angle that's not one of those special angles, and I have one side given. This is a good place for me to think about using right triangle trigonometry. All right, so remember, we look at the angle, and in reference to that angle, what do we have and what do we need? So we need the opposite leg, and we have the adjacent leg. So that's TOA. So we're going to use tangent. So we're going to write an equation, tangent of the angle, so of 54 is equal to x over 5. All right, so now it's those equations that we do know how to solve that we just reviewed. I'm going to put this over 1, I'm going to cross multiply, and I'm going to get 5 tan 54 equals x. I'm going to grab that calculator, and I'm going to do 5 tangent 54, and that gives me 6.8. So 6.9 actually in that case. So 6.9, so I know that this side is 6.9. Now if I wanted to find the hypotenuse now I have two sides, I could use the Pythagorean theorem. All right, let's try another one. All right, and actually my diagram's not so good. That 5 should have been right here. So fix that, and this is what we have. And so I look at the angle I'm given. I know it's a good decision to use trig because I can't use the Pythagorean theorem. I look at it, I have the opposite, and I need the adjacent. That again is TOA. Tangent comes up a lot. So tangent of the angle is equal to 5 over x. All right, so now I'm going to cross multiply. I'm going to get x tan 27. Now notice the x went in front. It's one of those special cases. So now I'm going to divide both sides by tan 27. So x equals 5 divided by tan 27. 5 divided by tan 27, which is 9.8. All right, I'm going to have you try C and D, and then I'll go over those answers tomorrow in class. But I want to make sure that we understand that there's times that you can use trig and all of the other facts if you need to find angle measure. So let's look at the Pentagon on the next page. So I know a Pentagon has 5 sides, and I was given a radius up here. I gave it in a funny location of 12. All right, so because I like to look at things straight up, I'm going to draw the radius over here and make it 12 for myself. All right, well, I need the central angle. Reminder, to find the central angle, we do 360 divided by 5. So 360 divided by 5 gives me, what's that, 72 degrees. So now I know that my central angle right here is 72 degrees. So that's already telling me that trig might come in handy here. All right, so I drop my apothem, my altitude of that little triangle, and when I do that, it's going to cut that 72 into 36 and 36. Now I'm going to redraw that right triangle on the side to make it a little bit easier for myself. 36, right angle, I have the hypotenuse, I need the apothem. I also need the this side right here to get me the perimeter. All right, so I'm going to work with the apothem first. So I'm going to do, let's see, I have the adjacent and the hypotenuse. I'm going to use cosine. So cosine of 36 equals x over 12, and I'm going to do 12 cosine 36, and that's going to give me, let's see, 12 cosine 36 is equal to 9.7. All right, so this is 9.7, so my apothem is 9.7. All right, now I've got to find y as well, so I'm going to do sine of 36 equals y over 12, and I'm going to cross multiply, and I get 12 sine 36 equals y. All right, so I get the calculator, 12 sine 36, and that gives me 7.1. Okay, so if this is 7.1, I need the whole side, so I have to double it, which is 14.2. I have to multiply 14.2 by 5 to get the perimeter. So 5 times 14.2, so 5 times 14.2 is equal to 71. So my perimeter is 71. My radius was 12, my side length was 14.2, and my angle, central angle, was 72 degrees. I'm ready to find the area, AP, so 9.7 times 71 all over 2. I'm going to put that right into my calculator. So 9.7 times, what was that, 71? Times 71 divided by 2, and I get an area of 344.4. So 344.4 units squared. All right, so that's our example for today. Tomorrow we're going to do a couple more practice in class, and then we will be practicing everything we've learned up to this point. All right, guys, have a great day.